Alright everybody, wanted to make a video that will help you on the homework problems. This is on December 2nd for AP Statistics, and I'm doing the model problems on the homework that is due on Thursday, December 4th, so model problem. And let me do 1A. So number 1 says that the EPA requires chemical plants to do frequent sampling of local groundwater sites to make sure that their chemicals are not seeping into and contaminating the ground. If the samples have a mean contamination of more than 800 parts per million, then it is considered contaminated. If statistically significant results are found, the company will be fined. Part A is name the test that should be used. So we should use a t-test, and the reason is we do not know the standard deviation, which I'll just put this symbol, of the population. By the way, the population is every piece of the ground. Right? It's not possible for us to know the standard deviation of the population. In other words, of every little piece of ground to know the standard deviation of the water there. That's crazy. Nobody could know that. Therefore, we need to use a t-test. If, by some miracle, we had known this, we could have used a z-test, which we've been calling normal CDF. Let's look at part B. Part B says identify the parameter of interest. The parameter, which is just a fancy way of saying a characteristic, the parameter we care about is the average mean contamination, because that's what they're measuring and that's what they're comparing. So we care about the mean contamination. And 1C, create the correct set of hypotheses. So the null hypothesis is that the mean contamination is equal to 800. In other words, 800, we should write parts per million. In other words, we assume that things are good. We assume things are okay. We assume that the contamination is just 800 parts per million, which is okay, no fine. The alternative hypothesis is that the mean contamination spelled wrong is greater than 800 parts per million. All right. And there we have it. So we're using a t-test because we don't know the standard deviation of the population. We care about the mean contamination. Our null hypothesis is that the mean contamination equals 800. In other words, that there's nothing wrong. The alternative hypothesis is something's wrong. The mean contamination is too big. Let me do problem 2 now. Problem 2 says a statistics teacher gave a quiz to his 8 a.m. class and his 9 a.m. class. There were 50 points on the quiz. The data for the two classes was as follows. Considering these two classes as random independent samples from the populations of 8 a.m. and 9 a.m. classes, do the data provide evidence at the 0.05 level of significance that 9 a.m. classes perform better than 8 a.m. classes? Let's find out. So here again, we want a two-sample t-test. Let me explain what we have here. Two-sample because there are two variables or two samples we are considering. We're looking at the group 1 and group 2. Right, group 1 and group 2. And it's a t-test because we do not know the standard deviation of the entire group together. we only know the S, so the standard deviation of each group individually. Each group individually. So it's a two-sample test because there are two samples, 8 a.m. class, 9 a.m. class. And it's a t-test because we do not know the standard deviation of the entire group. We only know it of each class individually. Part B says identify the parameter or parameters of interest. The parameter is the mean for the 9 a.m. class. 9 a.m. class. The mean score for the 9 a.m. class. I care about that, and I care about the mean of the 8 a.m. class. Mean score for the 8 a.m. class. All right, those are the two things I care about because I want to compare those. All right, create the hypotheses. The null hypothesis is what? The null hypothesis is that the 8 a.m. class and the 9 a.m. class do equally well. That the 9 a.m. class does equally well to the 8 a.m. class. Right? In other words, we always have the mean as the classes do equally well. The alternative, and remember this, if you watch the previous video, this is like saying Gatorade speed running is the same as no Gatorade speed running. Madison SAT scores are the same as YesPrep SAT scores. Blood pressure with the medicine equals blood pressure without the medicine. The alternative hypothesis, notice what they say, do the data provide evidence that 9 a.m. classes do better than 8 a.m. classes? So we want to know, is the mean for 9 a.m. greater than the mean for 8 a.m.? No, and alternative. And the last thing I want to do is I want to do one of the examples from the table here. And here we're asking you to tell us the name, whether it's a one sample or two sample test, the parameters we care about, and then the alternative hypothesis. So let me try to find a challenging one to do here. Let me do this third one here from this situation about a serum. So I'm doing situation 3. So a serum cholesterol level above 250 milligrams per deciliter of blood is a risk factor of cardiovascular disease in humans. At a medical center in St. Louis, a study to test the effectiveness of a new cholesterol-lowering drug was conducted. 100 people with cholesterol levels between 250 and 300 were available for the study. Flipping to the back of the page, 50 people were assigned at random to each of two groups. One group received the standard cholesterol-lowering medication, and the other group received the new drug. After taking the drug for 3 weeks, the 50 subjects who received the standard drug has a mean decrease of 10 grams and a standard deviation of 8. And the subjects who received the new drug has a mean of 18 grams, standard deviation of 12. Does the new drug appear to be more effective or less than treating lowering cholesterol? Okay, a lot of stuff here. The first thing they want us to do is the name of the test. We want a 2-sample t-test. Why? There are 2 samples. There's the old drug and there's the new drug. The parameters to define, we have to define mu1 and mu2. Mu1, let's say, is the mean with the old drug, and this is the mean with the new drug. And the alternative hypothesis is what? The alternative hypothesis is that, well, what are we trying to check here? We're trying to check that and by the way, this is the mean reduction. Notice, because they said that the mean reduction or mean decrease was 10 milligrams on the old drug, and the mean reduction on the new drug is 18 grams. So what is the alternative hypothesis? The alternative hypothesis is that mu1, the mean reduction for the old drug, so this is HA, alternative, is that the mean reduction of the old drug is less than the mean reduction of the new drug. And there we have it. Two sample tests. There are two groups, new drug, old drug. What are the parameters? The mean reduction of the old drug and the mean reduction of the new drug. And what is the alternative hypothesis? That the mean of the old drug, mean reduction, is less than the mean reduction of the new drug. These should help you complete everything on page 1 and page 2 of this handout. That's the goal for tomorrow.